Okay, and welcome back everyone. So here we go. This is going to be the second part of increasing and decreasing functions along with the first derivative test. We're going to knock out homework first though, so let's take a look at that and go from there. So let's see. First one was number 19, and that one was f of x equals x squared minus 8x. Okay, so first thing we want to do is find the critical numbers. So find the critical numbers. So how do we do that? Well, we take the derivative of the f of x. That's going to be f prime of x. And that's going to give us 2x minus 8. So there are two types of critical numbers. The first one are if there are discontinuities, and there are no discontinuities located in this since it's a polynomial. And second type are when we set f prime of x equal to 0. So f prime of x equal to 0 is going to imply 2x minus 8 is equal to 0, and x equals 4. Okay? So with x equals 4 as a critical number where the f prime of x is equal to 0, what does that mean? Well, that means that we have some sort of horizontal slope at x equals 4. Could be a min, could be a max, could be something else which we'll see next lecture. But for right now, could be a min, could be a max. So what do we do next? Well, next we want to make that table where we can use the first derivative test. So we're going to make the table. And the way you fill out the table is you put the critical numbers as little divider bars and write the value x equals 4 above like that. And now all you have to do is test values for your x that you feed into the f prime to see what the slope is at that location. Since the x equals 4 is the only place where the graph turns around where it has a min or a max, anywhere to the left is going to have the exact same slope behavior. Anywhere to the right is going to have the same slope behavior. And it will not change. So we can pick any value to the left of x equals 4, and whatever slope it has, if it's positive or negative, increasing or decreasing, it's going to continue that all the way up until it hits x equals 4. So I'm going to pick a value, a nice easy one, just for absolutely no reason, x equals 0. So I'm going to feed that into my f prime. So f prime of 0 is going to equal, well, f prime is 2x minus 8. So when I plug that 0 in for x, I'm going to get 0 minus 8, which gives me negative 8, which is negative. I don't really care about the value. What I care about is the sign of the answer. And since it is negative, the slope is negative, that means that it is decreasing. It's going down. Okay? Now I need a test value that is greater than 0, and it could be anything. I'll just do x equals 10 for no reason. Okay, if I plug f prime 10 in for f prime, I've got 2 times 10, which is going to give me 20, minus 8 is positive. So that is a positive value, which means that it is an increasing slope. So it's going down to the left of x equals 4 and up to the right of x equals 4, which means that x equals 4 we have a min. Oops, I completely overwrote that. So there we go. We have a minimum value. Alrighty. Now, it wants us to figure out for these problems, I think, where are the actual min values located? All your critical numbers. Where are the mins located? Where are the maxes located? And the reason that we do that is so that we can then sketch the graph. So we're going to start off, step 3 is going to be find the y values. Because we know what x values we need to look at. We need to look at x equals 4. Now we need to see where that's located. So how do I find what y value an x value corresponds to for a function? Well, all I'd have to do is plug that x value into the original f of x. So since I'm looking for x equals 4, I plug 4 into the f of x. So f of 4 is going to give me the y value. So that's going to give me 16 minus 32 is negative 16. So that value, that point of the min is going to be located at x equals 4, y equals negative 16. Okay? So to find the y values where these mins and maxes and cusps and things like that are located, all we do is we plug the x value into our original function. So one last time, I'm going to beat this horse down. I use f prime to tell me what the behavior of the graph is, whether it's increasing or decreasing. But if I want to know the actual location for a point, I plug that into the original f, not f prime. Okay? So now I'm going to clear the screen and do a quick little sketch of this. So what do we have? Well, we've got our function is f of x is equal to x squared minus 8x. And I know that I have a min located where? That was at 4, negative 16, right? Something like that. Okay, so what does this look like? Well, it looks like this. Imagine I can draw 16 of these real fast. 1, 2, 3, dot, 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 dot. Negative 16 right there. Pretty cool, huh? So I come over here, 1, 2, 3, 4. At 4, negative 16, I have a point. And that's really all I need to get the basic behavior of the graph. I know it's some minimum, so it's coming down, it's doing this thing like this. I could figure out where it crosses the x-axis so I could get an idea of how, squished or wide the parabola is. But I don't have to do that. For our purposes, we're perfectly fine with a sketch like this. So step 4 is going to be sketch a graph. That's all there is to it. And you can always check your answer on Desmos, which we'll be doing for more of the complicated ones. This one, I'm pretty sure it's a parabola that looks something like that. So I'm okay with that. Alrighty, so let's move on to the next one. Let me clear this. Okay, so moving on to the next homework, we have for number 23, we have f of x is equal to negative 7x cubed plus 21x plus 3. Okay? So first thing I always do is just scan the original f of x. Are there any discontinuities? No. This is a polynomial, so there can't be. And so now I'm going to do step 1 and look for my critical numbers. Alrighty? So the critical numbers are going to be where f prime of x is has a discontinuity or where it's equal to 0. Well, let's first find f prime of x. This will give me negative 21x squared plus 21 equals, we haven't set it equal to 0 yet. Jump the gun. So that's f prime of x. Now, if I want to find the critical number, I set that equal to 0. So f prime of x equals 0 implies negative 21x squared plus 21 is equal to 0. I'm going to divide every term by negative 21 just so I can get rid of all that. So if I do that, I'll wind up with x squared minus 1 equals 0, which is going to be x plus 1, x minus 1 equals 0. So x equals negative 1 and x equals positive 1 are going to be our critical numbers. Okay? So now that we have them, I can go to step 2. And step 2 is going to be make the table. So make the table. Alrighty? So what's my table going to look like? Well, it's going to have 2 values. I'm going to have x equals negative 1 for that one, and x equals positive 1 for that one. Alrighty? Now, I want to know what the behavior is on either side as far as what the slopes are doing. So I want to take a test value that is less than -1. So how about x equals -2? And where do I plug that in to see what the slope behavior is? Well, I'll plug that into f prime. So f prime of -2 equals, well, I plug a -2 in here. It becomes +4 times -21 is -84. That's definitely larger than 21, so this is negative, which means the behavior is going to be decreasing. And then for this interval right here, I need a value between -1 and 1. Oh, I don't know, maybe 1/2? No, let's do 0. So if we do 0, I do f prime of 0 equals, well, I get a 0 here. This term drops. I'm left with +21, which is definitely positive. So that means I have an increasing behavior for that interval. Finally, over here, a value greater than x equals 1. So what about x equals +2? Well, same thing that I got over here, because when I square it, it's +4, -84, and so I wind up with a negative number overall. So f prime of +2 is negative, which means we have a decreasing behavior. So what does that make x equals -1? Well, it's going down, then it's going up, so that is going to be a min for this one. And then over here, it's going up, then down, so this one's going to be a max. Okay, so what do I need to do now in order to be able to graph it? Well, I need to know what the y values are, where these mins and maxes are located. So how do I do that? Well, I plug in the values into the original function to get where they're located in the y. I know where they are in the x. They're at x equals -1, x equals +1. But where are they in the y? Well, I find that out by plugging the x value into the original equation. So f of -1 is going to give me, let's see, -7 times -1 plus 21 times -1 plus 3. So it's going to be +7. Minus 21 is -14, plus 3 is -11. Okay, so that value is going to be located at -1, -11. Okay, now for the next one, f of +1, that's going to give me -7 times +1, plus 21 times +1, plus 3, which is going to give me -7 plus 21 is 14, plus 3 is 17. So this is going to equal +17. That's the y value. So I get the point is at 117. Alrighty. So I am now ready to graph these two to do a sketch. So let me clear this. Draw a nice big graph. Something like that. I'm going to say that this is -11 and this is +18. And this is 1, and this is -1. Alrighty, so my 2 points are located at -1, -11. So right here is going to be one of my points. It's -1, -11. The other one is at +1, +18. So it's up here, 118. And I knew that this one should be a min, this should be a max, and that's a good thing because that totally fits what this graph is going to look like, which is going to be something like, whoops, that. Assuming I could draw a nice smooth curve, which I can't. It will look something like this. So, and of course you can see this is nowhere near to scale. This is going to be an extremely tall, skinny function if I drew it to scale. But that's good enough to see what the behavior is. Alrighty, so that was the second homework problem. Now let's jump on over to the third one. So here we go. Clearing the screen. Okay, so the last homework problem was number 43, I think. And number 43 was a trig problem. So f of x is equal to, we're going to have sine x plus cosine x. Okay? And we're also given information that we're only going to be looking between 0 and 2 pi, and it is non-inclusive. So we are looking for everything between 0 and 2 pi, but not including 0 or 2 pi. So First things first, any discontinuities? Nope. Sine and cosine are both continuous, so the sum of two continuous functions is continuous, so we don't have to worry about that. So we can go straight to finding the critical numbers. So let's go to that. I need my f prime function for that. So f prime of x is going to be, well, derivative of sine of x is going to give me cosine x. What's the derivative of cosine x? Exactly, it is not positive sine of x, it is negative sine x. So minus sine x. Okay. First type of critical number is discontinuities, where you have a discontinuity in the f prime but not in the f, which means you have a cusp. But that's not the case here. We don't have a cusp. This is again completely continuous. So we can now worry about when f prime of x equals 0. So that gives us when cosine x minus sine x equals 0. And that occurs when cosine x equals sine x. Alrighty, so unit circle time. Where on the unit circle does the x value equal the y value? Because that's what that is. Cosine is the x value, sine is the y value. So that occurs at two locations, right here, and this location is at pi over 4, and the values are going to be root 2 over 2, root 2 over 2, and down here, they're both going to be negative, so this is 5 pi over 4. I swear that's a 5. It's getting worse. Let me try that again. 5 pi over 4, and that's at negative root 2 over 2, negative root 2 over 2. Alrighty, so we have our two locations. We have x equals pi over 4 and x equals 5 pi over 4. Okay, those are our two critical numbers. Next step, what is it? Yep, now we have to make the table. So let's make the table. So if we make the table, we're going to fill it out. One of the points is going to be x equals pi over 4. The other one is going to be x equals 5 pi over 4. Okay, so we are ready to go. What do we need in order to see the behavior, the slopes? Well, we need to do a test value less than pi over 4. I'm going to pick right about here. I'm going to do pi over 6. And pi over 6 has an x value of root 3 over 2 and a y value of 1 over 2. So let me first put that down here. X equals pi over 6. So what does f prime of x give me? Well, f prime of x, well, let's see, cosine x minus sine x. Cosine is the x, sine is the y. So root 3 over 2 minus 1 over 2 is positive. So we're going to have an increasing function at that point. Then I need a value between pi over 4 and 5 pi over 4. So I'm going to just pick pi right here. And at that location, so at pi, we're going to have a value of negative 1, 0. So x equals pi. What does f prime look like? So f prime of pi is going to be cosine, which is our x value, so negative 1 minus 0 is negative. So that means the behavior is decreasing, the slope is down. And so we have two of the three intervals. Now let's go for the third one. Third one, I need a value greater than 5 pi over 4. How about, nice one right here. This is going to be 3 pi over 2. And that one has a value of 0, negative 1. So at x equals 3 pi over 2, I feed that into my f prime. So f prime of 3 pi over 2 is going to be, well, the x value, 0, minus negative 1, so positive 1, which is positive, which means that we have increasing behavior where the slope is up. Alrighty, so we now know that at x equals pi over 4, we have a max. and x equals 5 pi over 4, we have a min. Okay, now if we want to sketch this, we need to find where these mins and maxes are actually located in the y. We know where they are in the x, but now we need to know in the y. So let's clear this and figure that out. So step 3, we need the y values. So we have x equals pi over 4 and x equals 5 pi over 4. Those are the two we're going to be looking at. And our original function was f of x is equal to sine x plus cosine x. Okay, so let's feed x equals pi over 4 into the original function. So we get f of pi over 4 is going to be sine of pi over 4, which is positive root 2 over 2, plus cosine of pi over 4, which again is root 2 over 2. So we're going to have 2 root 2's over 2. They're going to cancel, which is just positive root 2, which is approximately 1.4. Okay, so we're going to get a point somewhere around at x equals pi over 4, y is going to be 1.4. Okay, now we do f of 5 pi over 4. F of 5 pi over 4, well, that is going to be negative root 2 over 2 minus root 2 over 2, which is going to be negative 2 root 2 over 2, which is negative root 2, or, oops, let me kill that one, approximately negative 1.4. Okay, so here we go. Now we can graph this. We're going to graph this out. Let's see. I'll do my graph way out. This is going to be 2 pi. This is going to be pi. This is going to be 5 pi over 4. And this one is going to be pi over 4. I'll make this one 1.4. This is negative 1.4, just to make it super simple to graph this thing. So I'm going to have, this one was 5 pi over 4, negative 1.4. Make sure I put that down. So here we go. I have a point at pi over 4, 1.4 right here. I have another point at 5 pi over 4, negative 1.4, so down here. And when I graph those out, this was a max, this was a min, which makes me super happy. So that means I have something that looks like this. And that's my function. And that's it. That's all you have to do to graph this. I know it seems like a lot of steps, and that was step 4, sketch the graph. But really, this is just a lot of practice. So we're going to go over some examples, and I'll turn you loose with some homework, and then we will be ready for the next lecture where we increase the number of things we can do to sketch graphs by hand. So let me clear this, and let's actually start on some more advanced examples. So here we go. Okay, so the first example is going to be, it's not too bad of a function, f of x equals, we're going to have x squared minus 4, and this is going to be to the 2/3 power. 2/3 power. Okay, so what does this look like? Well, this is actually, I want to be really clear, this is the cube root of quantity x squared minus 4 squared. Okay, so that's what it really looks like if I do it out in root notation. There are no discontinuities here because no matter what value I put in for my x, and I subtract 4, I'm going to square that value, which means it's going to be positive. And so it doesn't really even matter if that were, even if we're negative, because this is a cube root. So positive, negative, 0 doesn't matter. Cube root handles them all. So this is fine. Alrighty. So I can move straight to my first step, and that's going to be to find my critical numbers. So the first critical number that I want to look at is if the derivative has any discontinuity. So let me get the derivative. F prime of x is going to equal, all right, here we go. This is something raised to a power, and that something is not plain old x. So we know we're going to have a chain rule kicking in. So it's going to be the power rule with a chain rule. So this is going to be 2/3 times x squared minus 4 untouched to the negative 1/3 power, and then times the derivative of the interior, which is just going to be 2x. Okay? I can't make any sense out of this whatsoever in the form that it's in. So I'm going to rewrite it into root notation, which is going to shed some light onto what this thing actually looks like. So if I do that, I'm going to wind up with, I'm going to have 2 times 2x on the top. So it's going to be 4x on the top. And on the bottom, I'm going to have 3 times the cube root of x squared minus 4. That's supposed to be a cube. Okay, so how did I know that? Well, this quantity here was to the negative 1/3, which means it's a cube root, but it's negative, so it's down in the bottom. It's in the denominator. The 3 is in the denominator. The 2's up top, and this one is up top because it's to the positive first power, just not listed. So this is how it actually looks. And now I can look at it and start to figure out what my critical numbers are. So first thing I want to do is, are there any discontinuities? And so the discontinuities are going to pop up when the denominator is either imaginary or it goes to 0. I don't have to worry about it going imaginary because it is an odd root. Odd roots handle all values perfectly fine. But I do have to worry about the denominator going to 0 because there are some values that I can plug into x that's going to make this denominator 0. So let me go ahead and solve for that. I'm going to set it equal to 0 and solve. So 3 on the cube root of x squared minus 4 equals 0. So we're setting the bottom equal to 0, the denominator equal to 0 to find the discontinuities. So I'm going to divide both sides by 3, which is going to get rid of that. I'm going to have the cube root of x squared minus 4 equals 0. I'm going to cube both sides to get rid of that root. So that's just going to be x squared minus 4 equals 0, which means that x is equal to plus or minus 2. Okay? So at x equals negative 2 and x equals positive 2, I have a discontinuity. Now, up at the top, when I first looked at this, when I did the root out over here, were there any discontinuities anywhere? No. So if there are not discontinuities with f, but there are discontinuities with f prime, what are these values? Drum roll, dun, boom. They are cusps. They have to be. Okay? So I have found the points where f prime of x has a discontinuity. It has cusps. Now I need to know where f prime of x is equal to 0. So f prime, that's going to tell me where my mins and maxes are. So f prime of x equal to 0. Well, that implies that I set the top part equal to 0, right? Because that's when a fraction is equal to 0 is when the top is equal to 0. So 4x equals 0. Alrighty, that's not too bad. That means at x equals 0, I have a critical number. This is a min or a max right here. So I've got two cusps and a min or a max. Alrighty, so at x equals negative 2, x equals 0, and x equals positive 2, I have critical numbers. So x equals negative 2, 0, and positive 2. Now, next step is to build the table. So I'm going to clear this and build the table. So here we go. Step 2, make the table. Okay, so here we go. I'm going to do it out. I'm going to have x equals negative 2, x equals 0, and x equals positive 2. Okay. Now, I'm going to need what my f prime was equal to in order to fill out this table. So f prime of x was equal to, I'm going to do the notation that where I've written it all the way out where it makes sense. So I'm going to have 4x over 3 times the cube root of x squared minus 4. Okay, so here we go. I need a test value less than -2. How about -3? So x equals -3. And again, I'm looking for the slope behavior for this interval. And how do I find that? Well, I find that by plugging that test value into f prime. So f prime of -3 equals, all right, so here we go. I plug a -3 in here. I square it. I get a positive value that's going to be greater than 4. So this is positive, which means the cube root is positive. 3 times the cube root is positive. So I've got a positive on the bottom, and then when I multiply 4 times -3, I'm going to get a negative on top. So one more time. Actually, you know what? I'll even write that out. This is going to be 4 times -3 over 3 cube root of -3 squared minus 4. Okay? I won't do this all the time, but I will for this one because it's a little bit complicated. So -3 squared, that's going to be a positive 9. Positive 9 minus 4 is going to be a positive 5. Cube root of positive 5 is positive. 3 times that is positive. So I've got, on the bottom, I've got a positive value. 4 times -3 is negative on top. Negative divided by positive is a negative. So that means that the behavior is decreasing. This interval has a slope that is going down. Okay? Now a test value between -2 and 0. How about -1? So I'll plug that into my f prime. So f prime of -1 is equal to, well, I'm going to have 4. I'll do this one here, 4 times -1. And I'm going to have down here 3 on the cube root of, I'm going to have -1 squared minus 4. Okay? So -1 squared is 1, minus 4 is -3. The cube root of -3 is going to be negative. 3 times a negative is a negative. So this is going to be a negative on the bottom. And 4 times -1 is a negative on top. Negative divided by negative is a positive, which means that this behavior is increasing. Okay? Now I need a test value for between 0 and 2. I'll do +1 for that. So f prime of +1 is equal to, well, here we go, do another one. 4 times +1, and then it's going to be down on the bottom, 3 cube root of +1 squared minus 4. Well, I'm still going to get a negative on the bottom, right? Because +1 squared and -1 squared give me the same value, so it's going to be negative on the bottom, but the top is going to be positive. Positive divided by negative is a negative, so this behavior is decreasing. Alrighty, whew. Last but not least, a test value greater than 2. How about x equals 3? So for x equals 3, I'm going to get 4 times 3, and then it's going to be 3 on the cube root of 3 squared minus 4. 3 squared is 9, minus 4 is positive, cube root of positive is positive, 3 times positive is positive, so that is a positive. 4 times 3 is positive. Positive divided by positive is positive. So f prime of 3 is positive, which means I'm getting an increasing behavior to the right of x equals 2. Whew. So what does that mean I have at x equals -2? It's going down, then up, which means this is a min. What about at x equals 0? It's going up, then down. So that means I have a max. And then x equals +2, I've got down, then up, which is another min. All right, so now that we have all of these pieces done out, we need to find, if we want to sketch the graph, we have to see what the y values are for all of our mins and maxes. So that's going to be step 3. So let me clear this. Step 3, find the y values. Okay, so first thing I'm going to do is recopy my original function. I've got f of x is equal to, I'm going to do it like I did before in the root notation, the cube root of x squared minus 4 squared. Okay, so f of negative 2 is going to give me what? Well, that's going to be the cube root of, I'm going to have negative 2 squared minus 4 quantity squared. That's going to be 4 minus 4 is 0. 0 squared is 0. Cube root of 0 is 0. So 0. So that is located at negative 2, 0. That particular value. So now look at my next critical number, f of 0. And so f of 0 is going to be cube root of 0 squared minus 4 quantity squared. So this is going to be 0 minus 4 with negative 4 squared is 16. So this is just the cube root of 16. Can't really do much to that. That's 2 on the cube root of 2, but honestly, cube root of 16 is totally fine, just leaving it like that. So this is going to be located at 0 cube root of 16. Okay? Last but not least, f of 2. Well, f of 2 is going to give me the exact same thing I got for f of negative 2 because it's squared. So that is a 0 as well, which means I have 2, 0. That's where that location is. Now that I've done all of that, I can now sketch the graph. And so I can actually do that here because it's not a really complicated graph. So here we go. I have 1, 2, 1, 2, 1, 2. Oh, and that 1, 2, that's going to have to be up a little bit higher. It's a little bit less than 3. This one is approximately 2.8. And how did I, well, that's a terrible 2.8. But how did I know it was 2.8? I worked the problem out before. I didn't do this one on the fly. I wanted to look at like I at least knew a little bit when I was going over this. So the 3 locations are going to be at negative 2, 0, 0, 2.8, so somewhere up here, and finally 2, 0. So I found before that this was a min. So at negative 2, 0, I had a min. At 0, cube root of 16, I had a max. And then down here, I had a min. Does that make sense? Absolutely. And the other thing to keep in mind is that these are cusps. At 2 and negative 2, they're cusps. So what does this look like? Well, I'm going to have a nice smooth curve coming through and hitting right there at my max. And then since it's a cusp, it's going to be a very sharp V. So something like that. And that's it. That is what the function looks like if you graph it out. And I have graphed it out. It looks exactly like that. So there you go. One more down. Moving on. Here we go. Let me clear this and we'll move to the next example. Clear. Okay, so for the next example, let's have, f of x equals x to the 4th plus 1 over x squared. Okay, so as always, the first thing I do want to look at is I'll look to see if there are any discontinuities. And right off the bat, there is a discontinuity. What is it? Well, there's a discontinuity at x equals 0. What type of discontinuity is that? If I plug 0 into the bottom, it goes to 0. If I plug 0 into the top, it does not go to 0. It's a 1. So if the top doesn't go to 0, but the bottom does, what type of critter is x equals 0? Exactly. It is a vertical asymptote. That is going to be extremely helpful in graphing this function at the end. Vertical asymptotes are critical. No pun intended about what we've been doing. They are essential to being able to graph the graph by hand at the end. You have to be able to identify them. So that's why we always give a look-see to the function at the very beginning to see if there are any discontinuities. I know at x equals 0, I've got a vertical asymptote, so that's going to help me draw this one at the very, very end, sketch it in. So that's taken care of. Now I need to do step 1, go for the critical numbers. Okay, so the critical numbers are going to be where f prime has discontinuities and is equal to 0. So f prime of x is going to equal, well, this is a quotient. So the bottom, x squared, times derivative of the top, 4x cubed, minus the top, x squared, x to the fourth, plus 1, times derivative of the bottom, 2x, and all of that over the bottom squared. X squared squared gives me x to the fourth. Okay, I'm going to kind of make this look a little bit better. So f prime of x is going to equal 4x to the fifth minus 2x to the fifth minus 2x. It's going to happen when I distribute all of this, and that's over x to the fourth. Okay, so now f prime of x is going to equal 2x to the fifth minus 2x over x to the fourth. Okay, now let me kind of go over here where I want to go to a different page. Are there any discontinuities for this one? Well, yes, there is at x equals 0, but we already knew we had a discontinuity there, so we don't have to worry about it. If you have a discontinuity with your original function, you are definitely going to have a discontinuity for your f prime, since it's the slope of the original function, and if the original function doesn't exist at that point, the slope doesn't exist. So we knew that we had that already. We can now move on to when f prime of x equals 0. So f prime of x equals 0 implies, well, the top is equal to 0, right? So 2x to the fifth minus 2x equals 0. So this is going to be, if I factor out 2x, I'm going to be left with x to the fourth minus 1 equals 0. I can factor that. That becomes 2x times x squared plus 1 times x squared minus 1 equals 0. And now I can factor that. 2x times x squared plus 1 times x plus 1, x minus 1 equals 0. Alrighty? So this is going to give me critical numbers at x equals 0, x equals -1, and x equals +1. So if I write that out, I'll try to put that over here. I've got critical numbers at x equals -1, 0, and +1. Alrighty? So we're done with step 1. Now we can move on to step 2. So let me clear this. Okay, step 2, we want to make the table. So make the table. Well, we have x equals -1, x equals 0, and x equals +1. Alright, are we ready to go? Actually, what have I done wrong? Hopefully you've spotted it. Hopefully a few of y'all spotted it already. Hopefully now that I've said something, you're really spotting it. Yeah, exactly. We don't really have anything here. This is going to be some sort of discontinuity. I know it's going to be a vertical asymptote, right? I haven't really indicated that anywhere, but I'm going to go ahead and put that down. I still want to know what the behavior is to either side because that tells me if I have a vertical asymptote that looks like this, or a vertical asymptote that looks like this, or the other one would also be acceptable, the two others to this. So I need to still know what that behavior is, and the way that's going to happen is by actually finding what the behavior is for that interval. So we're still going to look at this. Even though I know there's a vertical asymptote there, it is a good idea to still see what the behavior is on this interval and this interval so that it helps us sketch afterwards. Okay, so we're still good. Only thing I need to do is I need to put the actual f prime in here. So f prime of x is equal to, we had 2x to the fifth minus 2x over x to the fourth. Okay, so I need a test value that is less than -1. So how about x equals -2? So f prime of -2 equals, well, I'll plug a -2 in here. I'm going to get, -32 times 2 is -64, minus -4, which is +4. So I'm still going to have a very large negative number on top. This is always going to be positive. No matter what I put in, x to the fourth is going to be positive. So negative divided by positive is negative. And that means the behavior is decreasing. Okay? Now I need a value between -1 and 0. Sorry, we are actually going to have to do fractions. So -1/2. And I will write this fraction out because this one's weird. If I do 2 times -1/2 to the fifth minus 2 times -1/2, and then I know the bottom is positive. I don't care what it is. It's positive because I'm raising it to the fourth power, whatever the value is. So I just need to worry about this. This is going to be -1 over 32 times 2 is going to be -1/16. -1/16, so this whole thing becomes -1/16. Over here, I have -2 times -1/2, which becomes +1. So -1/16 plus 1 is positive. So this is positive over positive. So f prime of -1/2 is positive, which means the behavior is increasing. And I'm going to erase this a little bit right here because it's getting too close to my table. Alrighty, so now I move on to a value that is between 0 and 1. So x equals 1/2. So x equals 1/2. When I plug it in, I'm going to have something a little strange. Let's see. Okay, so if I do that, I get, for x equals positive 1/2, I'm being attacked by my cat. Actually, my cat is attempting to get love, so this is interrupting my ability to write. So here we go. F prime of, oh gosh, this is not going to work. This is not going to work, cat. I'm going to have to pause the video. Hold on 1 second. Let me pause the video. Okay, sorry about that. That was my 23-pound Maine Coon serval mix, so I can't really do much when he's pushing against my head. So, anywho, one of the benefits is you ever come to the office hours for the Zoom chat is you might actually meet Thor. So he's pretty cool. Let's get back to this though. Here we go. So we have our test value is going to be x equals 1/2. So f prime of 1/2. When we plug that in, we're going to get, this is really cool, 2 times 1/2 to the fifth minus 2 times 1/2 over positive. This is going to be a small positive -1, which is going to equal a negative over a positive, which is negative. That's really cool. I love the way that this stuff worked out. So that's decreasing behavior. And then I'm going to have finally a test value greater than 1. Maybe I put in positive 2. If I do that, I'm going to wind up with a very large positive minus a small negative over positive, which is positive over positive. So f prime of 1 is going to be positive, or sorry, 2, not 1. 2 is going to be positive. So we're going to be having increasing behavior for that. Alrighty. So what do I have here? Well, it's going down then up. So this is going to be a min. What do I have here? It's going down then up. Again, I have a min. And what does the vertical asymptote behavior look like? Well, it's going to look like, let me actually dash that. That's the way you indicate vertical asymptotes. So it's going to look something like this on either side of it. So that's good to know. Slope is, wait a second. Let me think about that. So if the slope positive and negative, that is correct. Okay, it does look like that. Making sure, had to think for a second. That is a positive slope, that is a negative slope. Cool, we are good to go. So now all I have to do to be able to sketch this is to get the y values. So the y values are going to be located, well, all I need is this one and this one, because I know that one is a vertical asymptote. So I need my original function, so f of x was equal to, I've got x to the 4th plus 1 over x squared. So for f of negative 1, I'm going to get 1 plus 1 is 2 over 1, which is going to be positive 2. So positive 2, which means that point is at negative 1, 2. And then I'm going to have for positive 1, well, still going to be 1 plus 1 over 1, which is 2 again. So this is going to be at 1, 2. All right. So now we can sketch out this graph, and just keep in mind, this is a minimum, this is a minimum, okay? So let's clear this and sketch this out. Actually, you know what? I think I can sketch that right here. That way I can see everything when I'm doing it. So here we go. I'm going to have something like this. 1, 2, 1, 2, 1, 2, 1. Alrighty. I've got a min at negative 1, 2, negative 1, 2, and at 1, 2. How can I have a min here and here? The answer, vertical asymptote in the middle. That's what saves us. We have to be able to recognize that down here, down the y-axis, there's a vertical asymptote. Already know it has to look like this. So these points had better be minimums, both of them, because otherwise it is not going to look right. So this is going to do something like that, and this one is going to do something like that. And this is what the graph actually looks like. Pretty cool, huh? So, yes, and that was step number 4, sketch the graph. Alrighty, I think that's good enough. Let me stop this, go to the homework, and I will turn you loose. So here we go. Clear this. Okay, so before I give you your homework, do the following for every single one of these problems. All 4 of the steps. So find the critical numbers. That doesn't make sense. Find the critical numbers, step 1. Step 2, you want to make the table. Step 3, find the y values for all of the critical numbers. Step 4, sketch the graph. Okay, so for every one of the homeworks, do these 4 steps. Okay, and there honestly should be something like before 1, like maybe 0.5. Does f have any discontinuities? because that is going to help you out as you move through. Alrighty. So just try the following. You don't have to get every one of them right. It's just uh, as you can tell with the length of this video, um, working these out takes a long time. That's why in the past I've given a good chunk of this chapter as take home, because the problems are going to take, some of them are going to take about an hour to knock out each problem. So having as much time as you need in the form of a week or more for the take home, as it's a good thing. So here are the homework problems. Give them a good try. So for homework, this is still section 3.3, and it's going to be numbers 24, 31, and 38. And all these are starred, but 38 is a doozy. Good luck with it. It's a fun one. It's a quotient, which I know you love. So I will see you next time. Take care and stay safe. Bye bye.